Very good. Okay. Good evening, everybody. Thanks for joining us in the Zoom room today. My name's Daryl VK3AWA from Paradise Beach in Australia, where it's not paradise today, it's rainy. The presentation will take you through step by step how to build a flower pot antenna for 70 centimeters. At the end of the presentation, you'll have an idea of the construction detail, and I'll put the figures up so you can run through the same construction and build the same antenna with different dimensions for VHF 146. I forget the frequency, but it will come up when we get to the slide. Okay, what is a flower pot antenna? Well, it's originally started life, I think, as an antenna called a TLT, tuned transmission line. It's a simple, cheap, easy to construct half-wave dipole. It consists of a single length of RG58 coax and a coil former, and that's basically it. It doesn't require a ground plane or radial, so it's very, very simple to build due to the nature of the construction of the antenna, just one length of coax. It got its flower pot name because someone built one, I think for VHF, and they wanted to have the antenna inconspicuous. So they put it in a plant on their balcony, and it was disguised in the plant as part of the system for holding the plant upright, but it was actually an antenna. So I guess a stealth antenna. But that name sort of stuck, and it's the more favoured name than T2LT. So how does it work? Well, I'm just going to move that out of the way. I'm seeing things, that's better. The antenna is fed from the bottom through the coil, so it's one continuous length. However, it's electrically functions. Apologies, everybody. I'm not sure why that happened, but it wouldn't. I couldn't even select share; it wouldn't work. So everything's rebooted. So back to where we were. My apologies. How it works: the antenna is fed from the bottom. It electrically functions as a center-fed dipole. The RF travels along the inner conductor and the inside of the braid, and then the common mode current travels back on the outside down to the choke. So signal goes up, and part of it comes down the outside of the braid and is cut off by the choke to stop it from continuing on. Where to use it? HOAs, we don't have them here, but I think we might, but they're called something different. Apartments, portable operations, anything really. Replacement as a rubber ducky. You could really put one up in the house and hang it in the window on the curtain rod, or put it outside. It will do the job. My experience with the antennas, I've been building them for several years now. I started building them for POTA activations hanging from trees, and they worked so well that I started making them for other bands. So I've made them for all bands from 40 meters through to 70 centimeters. The 40 meter and 30 meter ones get a little bit long, but you can run them as horizontals. They work very well, and I've used them here for quite a few years, hanging from my antenna tree outside the shack, and had very, very good results. They have a very low angle of radiation, so they work well for DX for those people wanting to build a monoband HF antenna with very little expense and no radials and no counterpoise, so it'll do the job. I've done a lot of testing using Whisper, which is a weak signal propagation reporting software, and I've done comparative testing to other antennas that I use as a benchmark, and the flower pot antennas have really always worked very well. Required tools, not very much. And I have to apologize that all the measurements are in millimeters. So I'm hoping you'll have access to a ruler or a tape measure that has millimeters on there, but otherwise you'll have to do the conversions. But that's all I use, just a tape measure to measure the lengths of the coax required, some sort of mark and mark it off to make sure you're cutting and splicing in the right spot. Nothing fancy. Required materials, some RG58U, which is, I use Belden brand here, but any RG58U should do the trick. Just some electrical tape if you want to hold the coil in place. Once you've wound the coil onto the former, you'll understand what I'm talking about as we progress. Some heat shrink if you want to just put it over the midpoint to seal the coax, and a coax connector. I've modeled the antenna on 1/2-inch PVC pipe. Randy generously sent me some measurements, so I've actually simulated the piece of PVC pipe on my 3D printer. So that's a 3D printed part, which is exactly the same dimensions as your 1/2-inch PVC pipe over there. The antenna breakdown, you can see at the midpoint there, the braid and the outer plastic has been stripped from the coax. So you have an inner conductor, and then halfway down, or approximately halfway down, the braid and the sheath remains, and then you have a choke, which will cut off the common mode currents coming back down the antenna. When I'm building HF antennas, I don't strip the coax back. It's a monumental task. So what I do is I just leave 6 inches or so of the inner conductor, and then I solder the required length. I solder a length of hookup wire. So I'm not wasting coax, and B, I'm not spending half my life trying to strip the braid and the plastic off the conductor. It can be quite long on the lower HF bands. So the coax it's all one piece from the top of the inner conductor all the way down to where you put the connector on at the end. There's the antenna dimensions for 446 megahertz. Starting at the left-hand side, it's roughly 240 mil, and that worked out that it was 3 turns on 1/2-inch PVC diameter pipe, so that makes it fairly easy. So you've got 148 millimeter of the lower conductor, which is the braid and the outer covering on the coax, and then 150 millimeter stripped, just the inner conductor. Here's the PVC coil former dimensions. So I cut a length of pipe. I just made mine at 50 mils long, 18 millimeters spacing for the holes. And I drilled my holes at 8 millimeter, which is 5/16. It's a fairly tight fit for the coax, but it will hold it in place while you wind the 3 turns around the pipe. By the way, at the end of the presentation, there will be a PDF document put in the chat room. So all these slides will be available to you, so you can take the PDF document and have a play. Coax cable dimensions. The cable length is one length from the radio end to the antenna end. So the length of the cable required will really vary from user to user. the antenna itself for UHF will only require about 600 millimeters or so. And you've got to add this 600 millimeter to the length of the cable that you require to reach your radio. Keeping in mind that as we go up in the higher frequencies, you get more and more cable loss. So I would recommend keeping the length of coax to that required to reach the radio from the antenna. So you don't want to leave several meters of the cable coiled up under your desk. So how I make them, I sort of have the PVC former. I feed the coax through the hole, the bottom hole, leave about 600 mil, and the black tape is it's just there to stop the coax from unwrapping itself or coiling up, so I could take the photo. So I feed 600 mil or so of coax through the bottom hole. That'll be more than enough. You'll trim off the excess when you finish the rest of the build. So there's the next step. Tightly wind 3 turns on the coax. Get this as tight as you can. It can be a bit hard on the thumbs, but you've got to keep working the coax to make sure it's nice and tight. And then you can put some insulation tape, or I just run a cable tie underneath and then over the top of the coil and hold it in place. So you need that sort of held quite tight. Remove the outside sheath and the braid 148 millimeters up. I measure from the top of the hole, the top hole, measure from there 148 millimeter. Then use your sharp knife to just run the knife around the coax at that point. And I just run the knife along the coax, along that 150 millimeter line. It won't cut into the inner conductor because you're running along the outside braid. And that's the easiest way to get the plastic sheath off. So make a circular cut at the 148 millimeter mark, then run your knife along from that mark to the end of the coax, and then just peel off the plastic. The braid can be sort of pushed back and concertinaed back towards the coil, and that will fan out near the point where it needs to be cut at the end of the 148 millimeter. It's quite a tricky process, but be careful and just go nice and slowly, and try not to cut the insulation on the inner conductor. You want that to remain with no cuts in it. And I'm going to keep talking while I get up and shut the door because the wind's blowing the door open. It's freezing here. We have quite a storm here at the moment. There's the finished antenna, and shown in the picture are a couple of PL259 to SMA converters, depending on whether you need male or female, depending on the radio you're using. But that's how my antennas are completed there. I've got a PL259 on the end, and I use adapters as required. I don't put them in PVC pipe normally. Some final thoughts, and there is some extra stuff here after the final thoughts. Measurements in the presentation are theoretical, are taken off a calculator, and they'll give you acceptable results. If you're sort of playing around with HF version of the antenna, you'd make that center conductor a little bit longer than the calculated value, and just tune that center conductor to optimum SWR. That's all that's required. You don't have to play around with the bottom half of the antenna, and just trim the top. And I've never built one of these antennas and not been able to tune it onto the resonant frequency that I want. So very happy with the way they come out. I normally just use PL259s because I've got a bucket load of them here, and I use them for everything I do. I don't operate build antennas much on UHF, so I don't need end connectors or what have you. So PL259s and the appropriate adapter for the handheld radios on VHF or UHF. You can cable tie a piece of string to the top of the antenna, and you can use that to hang the antenna wherever you want it. If you want to operate it indoors, it'll work quite well. You can hang it in the window that's facing the repeater of choice, and put it on the curtain rod or whatever you have to hook it on, and it'll work. Or you can put it outside. You can enclose the antenna in a length of 1/2-inch PVC pipe, and I used one here for quite a few years, and that was my base radio antenna on 2 meters. And I've got a picture of it showing how I made it later on in the extras. So there's the link to the flowerpot calculator, which is an online calculator, and you just put in your resonant frequency of choice, and you hit the calculate button, and it will give you the measurements. Unfortunately, the measurements again will be in millimeters, but it'll give you the measurements for the top element, the bottom element, and the coil. The coil will be given to you as a length of coax, so you can put that on really any diameter former, and you know, as you go down in frequency, the former needs to be bigger in diameter because it gets difficult to wind. You couldn't wind, say, a couple of meters of the coil on a piece of 1/2-inch PVC pipe. You'd want to probably go up to 2-inch or even more, maybe 3-inch on the lower frequencies. But so the dimensions of the coil are actually given, not what the diameter of the former required. Some extra stuff. Pretty creative. This is the coil former using a 1/2-inch PVC. If you want to build an antenna for VHF, the hole diameters are 54 millimeter apart, and that will allow you to wind 9 turns. I think I've got a picture of it coming up next. So there's your coil former for a VHF version of the antenna. Building is exactly the same. It's just the dimensions that change. And there's your dimensions for a VHF version of the antenna. Note it's 9 turns on the 1/2-inch PVC former, so you need that extra distance from the hole centers. Additional pics. The top one shows just a piece of cord attached to the top of the antenna, cable tied in place. And that's what I do if I'm going to put one of the antennas up my antenna tree outside the shack here. I just have a permanent piece of cord going up to the top of the tree, and I'd use it as a pulley system and just pull the antennas up and down. So I can drop an antenna very quickly and put another one up. There's just some variations of SO239 to SMA coax adapters that are readily available on the normal outlets, AliExpress or whatever your weapon of choice is, Amazon. And the bottom picture shows my 2-meter base station flowerpot antenna. So the actual antenna is up, shown in the top portion. And ideal about this is you can use the same piece of PVC pipe, make it as long as you practically can, and that's your mast. So you can have the mast section of the antenna all in one length and just drill the appropriate holes for the coax to come out and back in again. And that can be a bit of a fishing expedition, but you can do it. And I normally just tie a piece of fishing line to the top of the antenna, pull it over the top of the antenna at the top and the PVC pipe, and put a cap on. and that holds the fishing line, stops the antenna from trying to fall back down the pipe. That's about it. That's about all I could come up with. So I'm quite happy to take questions if there's any there. And thanks for your participation, and apologies for the technical hiccup that I have no idea what happened. But anyway, we got back there. Thanks, thanks everybody.
All right, thank you, Daryl. I removed the thing so people can unmute themselves to ask questions.
Okay, very good.
Thank you, Daryl.
Might want to stop screen sharing.
Yep, I will.
Thank you, Daryl. Very well done.
It's not
nice job, Daryl.
Nice job, Daryl. Thank you.
I'll help you out, Daryl.
You're welcome.
Very
I take it I'm
informative.
still sharing.
There we go.
Can you put the link back?
Am I still sharing or not sharing?
You're not sharing it.
Okay.
He's gonna be sending the presentation in the chat in a few
Right.
moments, and so you can get the link from there.
Correct. I'm doing that as we speak.
Nice job, Daryl.
I'd like to comment how easy they are to build. One day I needed a 130 something meg antenna to track some weather balloons, and I just got a length of conduit, and 20 minutes later I had an antenna. And so that they really are easy to build, and they just work.
I think for the guys with the HTs in the house, build one, run it down to your HT, and hang the antenna on your curtain rod. It's certainly better than a rubber duck.
Yes, it is. And that document is in the chat now for anybody that wants to access it.
Thank you, Daryl, and we'll share this this PDF elsewhere. So if you forget to download it or misplaced it, we'll have a place for it.
Anybody else have any
Thanks, Joe.
questions for Daryl?
Daryl, I got a couple of one question and one clarification. Question is,
Go ahead.
I couldn't tell from your diagram exactly, and I didn't understand the commentary enough to figure this out, so bear with me. When you make the cut on the top part of the antenna to remove the shielding, are you removing the total shielding, or are you folding it back on itself?
They're actually removing it all, Mike. You're removing the plastic and the braid.
Okay, that's what I was wanting to clarify. The other thing was that if you're going to put it in to a PVC, are you specifying that it should be in the thin version versus Schedule 40 type of PVC?
You've got me. I don't have an answer for that.
Oh, here in the States, we have two versions of PVC. We have Schedule 40, which is used for water pipes inside the home. And you have a Schedule 80, which is primarily used underground for sprinkler systems. And it's a much thinner wall.
Yeah, I gave him the dimensions for the Schedule 40.
Pardon me?
He has the dimension for Schedule 40.
Okay. My point was, and then is that Ed Thong, who has a very nice JPO antenna out there on the market, has always specified, because of its weakest points, that you should use a thinner grade of PVC. Now, Charles may have some comments on that.
That's what this reminded me of too, Mike, was the Ed Fong. Mm-hmm.
Mm-hmm.
Yep. Mm-hmm.
What I do, Mike, if I want to test the PVC suitability, I cut a short section of it and put it in the microwave oven. If it doesn't, if it doesn't get hot, then it's not conductive.
Well,
And that works.
I wasn't thinking about the conductivity. I was thinking about the acting almost like a shield, the thickness of it.
Same
I'd
thing.
say, yeah, same thing.
Okay.
So what do you run electrical wires through? Which around America?
I don't, Randy, I don't know what the schedule is on it, but it's a drape pipe. But isn't there a plumber out there, electrician that would know that?
It's about the same thickness,
Is it? Yeah.
roughly.
It's,
Yeah. Yeah, the big advantage to the conduit, the gray stuff, is that it is more UV stable.
okay.
Yeah. That's what I used, electrical conduit. Well, Daryl, you'd be pleased to know the sun's come out.
Nice job, Dale.
Oh,
Thanks, Lawrence.
one other question, Daryl. What plant do you recommend?
Rose. Well, roses for UHF and poppies for VHF.
Well, my wife has a fiddler fig. You ever seen one of those?
Yeah.
And hers is about 6 feet tall, so he could probably handle the VHF version.
Did you ever do a 10-meter one?
Yeah.
Daryl?
Yeah, 10-meter ones work very well.
I think that would be great. Yeah.
So it's
for the technicians,
and the easy way to work out what length it is, just if it's 10 meters, well, the antenna is going to be a half wavelength, so it's a 5-meter long antenna.
Use fake flowers, Mike.
Well, hey, I'm classy. I use silicone.
Mike, I would strongly advise you to stay away from the fiddle leaf fig if you value your life.
Is it dangerous?
Well, thank you, Daryl, for doing all that hard work, modeling it for us, and I'm sure we'll get a lot of hits on our page with it. And I think for 10 meters for a technician, that would be a really nice project.
Yeah,
for,
that actually
like for you, Lawrence, you're just getting started. So it'd be a relatively cheap antenna, get you on 10 meters.
Oh, geez. I don't think I'm ready to get that far. My buddy Jim and Brian had both told me to first get my first order in HF wig and have it assembled, and then in the future build. But I just am following what my ham friends say.
Okay. Well, again, thank you, Daryl.
Yeah, thanks a lot, Dale.
Thanks,
I enjoyed it.
Thank you, Daryl.
Great job, Daryl, and thank you.
Yeah.
You're welcome.